Okay, before I get on to giving an example of a function rank beats when one rank beats another, I want to introduce the concept of a data type invariant. So whenever we introduce a data type where the values of the data type are not precise, we're not precisely modeling what we want, then we should introduce a data type invariant which will help us with, for example, testing. So what do I mean about not being precise? Well, we can write numeric 2s and numeric 10s, but we can also write numeric 201s is a perfectly good value, or maybe even more absurdly, negative numbers. So now we have playing cards with a whole bunch of values which are not valid values. And that's a kind of trade-off. It's actually convenient to structure the data type in this form. It's still quite a small data type, but we've ended up using a value, a type, which is not a good fit for our data type. So it's good practice then to introduce a data type invariant, and that's something we would most likely use in quick check properties. For example, to check that whenever we generate a rank in any context, we never generate an invalid rank. For example, if we want to generate a pack of cards, we want to make sure that every rank in that pack of cards is a valid one. So one natural way to do that is to introduce a data type invariant, a property that should always be true of every rank that appears in a program. So I'm going to call that, using quick check style naming, prop rank. And it's an example of pattern matching over this data type. So when we define pattern matching, this is going to be the important case. If we have a numeric card, what does a numeric card look like? Well, this one down here you can see, numeric 2. So let's define a pattern over that. A numeric n, so this is a card which is a numeric card with a value n. And the property for this kind of card is that the value n should be bigger than 1 and, Boolean and, that's that guy, the value n should be less than or equal to 10. So this is checking that the value, the numeric card, is in a valid range. Now this is a perfectly okay definition as far as it goes. If we ask prop rank numeric 2, I keep forgetting to reload the file, you're sure you'll do the same, then that's indeed true, but a numeric 22, that's not a valid card. What about, we get an exception. Maybe what we should have done is set this incomplete patterns warning. That's a directive, that's something telling the interpreter to give us a bit more information. Let me reload that file. Okay, I've reloaded that file now. I had to actually change the file by putting a space in it just to tell it that it had changed. And you see now what happens with this incomplete pattern warning. It's not an error, so we've still successfully loaded the module, and so we can run any of the functions in it. But we have got extra information that's warning us that these patterns are not matched. So let's go ahead and match those patterns and tell the function what it should do if it gets one of these. So what we're doing now is telling the we're describing what the prop rank function should do with any other value other than a numeric. So if it's not a numeric, then is it a valid card? Well, yes, because it's either Jack, Queen, King, or Ace, one of these four. Any of those will be valid. So we can actually use our little don't care pattern. We don't actually care what it is. If it's not numeric, then it is valid. So the answer should be true. It's a valid card.